I already see you have quite a selection here. I haven't seen this in too much detail before, so this is going to be a fun trip down memory lane. So what we have here is the unit that was used for the filming of the Kickstarter.
Yeah.
So the first concepts for this are really, really old. It was around the time where I really started doing more of my own CAD work, more of my video editing or photo editing work.
Okay. So, from sitting on a bed in Taiwan to sitting in our office in the Netherlands, Moritz, welcome back.
Nice to be back.
Yeah, it's nice to have you back. How was your trip? How was Taiwan?
Exciting.
Yeah?
I really like being there, and it is amazing to work with our development studio that closely and really push the project forward every single day, and just see the progress that we can do with one iteration after another, going through 4, 5, 6 iterations in a single week. And also, of course, being with the manufacturing halls directly. So all of the factory tours, inspections, quality control, all of these kinds of steps. Every time we do it again, it's an amazing experience.
Nice. Do you have any plans to go back anytime soon?
Oh yeah, absolutely. At this point, the question is more when I'm here,
Right.
and not when I'm there, but basically for as long as it takes to get everything ready, especially on the development side, we will keep going back to Taipei.
Nice. Yeah, hoping to also potentially share some content while you're there next time.
Absolutely.
But in the meantime, we're here in the Netherlands office, and we have a bunch of really interesting prototypes in front of us, ranging from the first ever paper prototype that Moritz did in his bedroom, all the way to the relatively final or close to final design that we have featured in our Kickstarter, and also everything in between.
You say that, but we still have quite a few things to do.
That is true. Yeah, there's definitely still a lot of work to do, I think, in general, but
we'll talk about that in detail.
Yes, indeed.
I already see you have quite a selection here. I haven't seen this in too much detail before, so this is going to be a fun trip down memory lane.
Yes, indeed. I can imagine. Yeah, a lot of these kind of popping up from the warehouse or some spare drawers in the office.
Shelves and shelves full of prototypes.
Running around trying to find that prototype, this prototype.
Yeah.
But yeah, super excited to go through these with you, Moritz. And yeah, maybe
Absolutely.
we can start the journey in the beginning. So maybe we can dive deeper into what this contraption is.
Right. We start with the most jank part.
Yeah, naturally.
Yeah, of course. So basically, I've mentioned it before. Create didn't start out as a keyboard. It started out as a macropad. And the idea really was just to get a bit of an understanding and a bit of a feeling for what that would look like, what we would want from these pads. We wanted certain features in certain locations. So instead of designing around a QWERTY keyboard and then adding these features around it, we started with these. So that is especially the knob you see here.
Yeah.
So the rotating knob, not a modular slot, was what we started with and what we built the entire product around. And for that, the position of it and the usability of it always was in the foreground. That was always the key focus. And then we kind of built a keyboard around that. And in the beginning, not even a keyboard, just one half. And the battery, we wanted to keep things slim, so that had to move into a separate bar. So that's why we have this bar in the back.
This in the top here.
Exactly. And we then started adding dock ports into that, pass through these kinds of features. But yeah, what you see here is really just cardboard and foam cut together, just to get an understanding of the shape and the sizes, to really get it a little bit visual before even 3D printing is worth it.
Yeah,
and
of course.
I've mentioned that this one is really old. This one is from before we even started our first company. So these units, what we will talk about here, is before the time of ARC, before we started making our phone cases. So that was different times. Correct.
When was this? 2015?
Yeah, so the first concepts for this are really, really old. It was around the time where I really started doing more of my own CAD work, more of my video editing or photo editing work, and noticed that keywells just aren't really fit for that. So that was indeed like 2015, 2016, somewhere in that time frame.
Okay, nice. So yeah, so it went from this sort of mock-up, and this is the first 3D print that you made, right?
Correct. The first one we made here with our current equipment. We made a few different dummies beforehand, a few like with home printers, etc.
Right.
A few different like dimensions and tests, but yeah, this is the first like significant different design, different change that we made, where we tested out making the entire part tentable, and where we also already knew that this was not going to just be a macropad, but was going to move towards a keyboard.
So the tenting is already present here.
Yes, so the tenting is present here, which you can see on the teardrop shape of the module, which wasn't a module at the time, but yeah. That teardrop shape was created to give us more area that will contact the table when in a tented position, so that you would have this entire line touch the table while at this angle tented. And you already see the slight forward angle of this. We in the beginning tested with a perfectly straight angle, but noticed very quickly that would not work, made one with a variable hinge where you could test the angle. Right. And that is why in every single version afterwards, you will see that angle being very, very steady. Because we made some very early tests that would tell us what would work for the tenting, but also for the usability, and what would align with your hand well.
Nice. And really quickly, like in terms of materials being used here, obviously from paper and foam to now a 3D printing, like what type of facilities or like 3D printers did you use to create these? Because we actually are like next door to a 3D printing company as well. So were there any like collaborations or cross-pollination happening there, like using their facilities and like helping us create our product? Or
so in 2015, 2016, when I would hand wire my keyboards, I would usually use regular FDM, fused deposition modeling printers, similar to what we see over here. But like very simple methods to do a few quick tests. For these later ones and most of the white parts we see here, we used some much more industrial machinery. These are done on powder printers. So these are all made out of nylon entirely, which just allows for a much nicer printing process, much better finish, and much less work in between. So it allows you to iterate much faster.
Right.
So we have like, 5 units on here of that printer, but we made hundreds of them.
Yeah. So would you say that the access to these facilities actually really helped?
Yeah, absolutely. The types of facilities you have available really dictate what you can do in your prototyping. Not only how fast you can do it, but also the kinds of things you can test in the first place. So testing complicated hollow structures or parts that have a lot of internal componentry become really complicated if you want to do them on FDM, but are trivial if you do them in powder. And it saves you a lot of having to arrange parts, having to figure out how to print things, having to do post cleanup, etc.
Right.
It just makes that entire process a lot faster. And speed really is what matters if you want to go through 100 iterations on something.
Of course, yeah. And I mean, there are quite a few iterations going across this sort of table, right? Could you point out like the key kind of, because I like with product design, it's always kind of like you have the design, you create prototypes, and then you say, okay, what are the learnings from that prototype? Iterate. Then we have kind of like the result of those iterations. So yeah, like would be interesting to maybe see like the key outputs of the iteration processes that we can see on the table here.
Yeah, it's always build, test, iterate.
Right.
Yeah, no, we have a few very interesting points here. But I think even more interesting than the significant changes is the things that we went back on. So 2 steps forward, 1 step back.
Yeah.
Because you very often test things that just weren't good or that didn't work out. So I think those are also going to be fun as we go through the entire list with where that happened.
Right.
I mean, if we start at the very beginning, of course, designing not around a keyboard but around a dial, as I've just mentioned, is a really, really significant departure from what is commonly done, and probably what makes Create the most unique, that it isn't designed around being a keyboard first.
Right.
The second part was, of course, moving from macropad to a keyboard. So yeah, that of course changed the entire design.
Right.
Thirdly, the feature we all know, the modularity. That feature is what now stands out and what now allows so many new people to interact with it who would have chosen different configurations or different parts for their keyboard. because we noticed that it's not just one workflow where you need your main tool of work in a certain location and not somewhere in a corner away or on a completely different device. That is even worse. And yeah, the modularity feature really brought that together. And as we can see with this unit, it also very clearly shows you where we started this with my own work at the time, 3D. And the entire 3D navigation was the big topic that made me push towards modular. And yeah, then of course noticing how interesting mice, etc. are, made that an obvious next step. But yeah, we then see a lot of small iterations with different shapes, different layouts, different thumb clusters, a lot of research going into all of these things. So I'll talk about those at length later on. But also smaller things like the module size, where we started out with the module at around 56 millimeter, 54 millimeter on some iterations, and then tried out different sizes all the way to where we are now to 69 millimeters. And that was a very interesting process, as with every step we had to see, does it make the features we have better? Does it make something worse? What do we get for it in which module? And finding that sweet spot where every feature that you want and need is in there, but where you don't waste space for portability or for usability. So that was a very interesting journey, testing dials between 80 and 50 millimeters, and then testing 3D navigation devices between 80 and 50 millimeters, and so on. So that was a very, very, very interesting process.
Nice.
And then as we get into functional versions, there's of course a completely different story here. And between anything that is printed and anything that is manufactured out of metal and plastics is of course a huge step, because here you have all of the DFM and all of the like scaling and production method differences, where with the printer, I mentioned it before, you can just avoid any of the how would you ever actually make this part, because the printer will do pretty much anything. These powder printers even more so than anything else. And then going from there to, okay, this is how we want everything to be made. Of course, that is a consideration every step beforehand, but it's always different between what you conceive you will do and then having to actually do it.
Right.
So that was also like a significant step.
Okay, interesting. So yeah, to circle back to the like overall timeline here.
Yeah.
The step between this and this, I think, is quite notable as well, because this one has still this traditional straight keyboard form factor.
Right.
With no thumb clustered keys at all.
Right.
And then because the keys were initially on the dial, right?
Right. So this was a non-modular version.
Right.
So when we switched to the modularity, that brought up a lot of questions. One of those questions, how do I press buttons on my touchpad, and how do I get modifier keys when I'm on a 3D nav, and how do I use this now as a regular keyboard? Because initially when the earlier ones were conceived, they weren't meant as a keyboard. So the moment we moved to a keyboard, we're like, well, more thumb keys is nice. So let's go with keys on our dock. And then those were added in, and they were first added in a way to like curve around the module. That seemed the most intuitive at the time, but I don't think you need a heat map analysis to figure out that this one is a problem. The heat map analysis comes later when you actually try to tune them, but this was very short-lived before we moved on to an inverse curve to the module. But yeah, still lots of interesting iterations here. And indeed, the curve. The curve mainly wasn't there in the beginning due to the production methods we had looked at. But we will talk about the actual body construction at length later on, because that was a very interesting procedure. But yeah, the curve just matches the hand better.
Right.
It allows for a more ergonomic shape. Exactly. With your pinky being a bit shorter and the keys adjusting to that. So that was a very natural choice, which once you look into split keyboards is kind of a no-brainer. And the only reason we omitted it in prior versions because we weren't sure yet where it would land. Is it a keyboard or is it not? But once we decided, okay, it will be a keyboard, all of these features were basically immediate.
Yeah. Okay, interesting. So this is the first iteration that essentially had the modularity, or
absolutely, yeah.
There we go. Yeah.
So these just snap in place. Yeah.
Okay, interesting. And then the step from here to, I guess, here is the next one?
Yeah, of course. So here you can then see that we immediately inverted the dock key direction. We also removed one of the keys on the 8th column because of how it would interfere with the mechanism on the inside. We changed how the spacebar layout would be done. A few of the smaller tests, but these two are also fairly close to each other. And we refined some of the modules especially, and some of how they would be located and where they would fit. And that, I will also go to the next one directly. That experimentation on the module side is also what you will see in the next one, where we started really testing out different features. This was where we made most of our prototypes, just integrating small features, testing out different directions. For example, that you now here have the cutout for the wireless charging.
Yeah.
We initially experimented around with making the base out of plastic or putting a plastic sheet under the keyboard, but the coil would never fit in a good spot. We would always run into height limitations. Every module would get too high, especially the touchpad. So all of that required a lot of experimentation and testing until we decided, okay, let's just cut it out. Let's make our own dock. Let's put the magnets in certain configurations that would work with this. And let's charge through that area, charge into the module directly instead of into the keyboard.
So the reason why there's a cutout is essentially to allow for the Qi coil charging to pass through here, as opposed to this having a base plate would prevent that connection from being
right. So there are two options if you have a base plate. Either you have the coil inside of that base plate and you
Right.
charge the keyboard directly, which was the idea on prior versions, or well, you put a metal plate there, and I don't know if you've ever tried putting a metal plate on a Qi wireless charger. Please don't do it. They will heat up quite quickly because the the coil detects the metal plate as a secondary device and will start inducing electricity.
Crazy. So like, because I guess that is a good explanation as to why we have this sort of handcuff design, as we've seen on our social media. People have been saying that the keyboard looks like a handcuff without modules in. But I guess that's a good explanation as to why that exists.
Right. Yeah.
Okay, and I see also a little bit of a difference between the thumb cluster positioning. This one being a little bit more offset than this one.
So here we now really get into the heat map analysis.
Right.
So basically, when you design a thumb cluster, you try to give most people the most available keys and the easiest movement possible. That far, not much news, and finding and generating these heat maps also not all that difficult. The problem comes when you add additional limitations. For us, for example, that is the module. You want to still be able to reach the module, but you don't want to hit your thumb into the module while you're using the keys.
Right.
So that led to a lot of back and forth on how exactly we would want to arrange them. And that was also always a consideration for how large we would make the module. Because in theory, why not go for 80 millimeters, right? But the spacing of that area would simply create some limiting factors there.
Mm-hmm.
And initially, we had assumed the thumb cluster would have to be much closer to the hand. But as we tested with more people for longer times and would get their posture correct and their hand arrangement into a more standard use case and not just a first intuition, we noticed that their hand is actually much further up on the thumb, and that would shift the entire heat map slightly further outward. So all of the future iterations had the thumb cluster about 1.5 centimeters higher. So in later iterations, you will only see the thumb cluster move by a few millimeters back and forth, but there we still had huge shifts because of how the rest of the board was designed and how that shifted the hand.
Yeah.
One very significant part of that shift is that we have added in the number row again.
Yeah, I was also going to mention that,
Yeah, the moment we added in a number row, everyone's hand suddenly moved up and claw gripped a bit more so that they would reach the number row comfortably. And that additional movement up to the number row caused them to also be higher up with their thumb. So that changed the heat maps in the testing.
Nice.
Hence the shift from something much lower to something much higher.
Yeah. And this is, I guess, sort of the, I don't want to say final, but the first sort of like, okay, this is probably going to be the form factor going forward, because I noticed that this compared to that, like in comparison to the last one, I feel like a lot less has changed from here to there between this and this?
I think naturally in prototyping, your changes become smaller.
Yeah, true.
You should always iterate on the biggest change first.
Yeah.
So when you know what is the biggest topic, the thing that causes the most conversation, that's what you want to iterate on the most heavily.
Yeah.
And as you get further into your product, you want to make your changes smaller, because every large change will have a huge chain reaction to everything else. So with every single step we will go through, the changes will become smaller.
Mhm.
That is simply the nature of it. There is one very big exception. We will talk about that one in a
Yes,
second.
100%.
Yeah. So usually that is the case where changes do become smaller. And
Right.
here we have a few of these experimentations that we did in that period of time that
Mhm.
show that quite well.
Yeah, because I guess here was also a little bit of an experimentation in terms of a keywell type of design,
Yeah.
which I think is quite common in the ergonomic keyboard space, to have
Right.
this really intense keywell to make it more achievable to reach certain keys
Right.
with your hand. And this was abandoned, I guess, as well because of.
Yeah, so this is a funny story. So here we really go into the experimentation on certain features. And one of these was indeed a keywell, because we saw at this point already that in the feedback, the ergonomics features were well received. But one feature that was pointed out that we didn't really integrate was a keywell. And as you can see, we still don't.
Right.
So we tested a lot of dactyl menu forms and other keyboards of this type and printed a shelf full of them.
Okay.
But the problem with all of these were that they would always fit for a certain hand and not for anyone else. So these really do need to be customized to your own hand.
Right, yeah.
And especially with the module being added in, it made reaching the module very, very difficult, because moving your hand across the keyboard, across columns, is very challenging due to the height changes.
Yeah.
And for the module, this can often be necessary. So the shape of the keywell naturally tended to interfere with the module use. And for us, we built a keyboard around a module and not a module around a keyboard. So that ended up becoming the disqualifying factor for this.
Very interesting, yeah. But I guess, it's also definitely not the most accessible to a general group of people, I think, because I've even seen websites where you input the dimensions of your hand, and it gives you a model that you can print out that is specifically designed for your hand, right?
Yeah, that's exactly what this is.
Okay.
That is dactyl menu form. These ones are, of course, quite heavily modified, but that is exactly how this works. You put in which columns, which rows, which keys you want, what spacing you want, how you want them to be arranged, and you get these pre-made CAD files that you can then modify.
Right. Yeah, interesting. Super interesting. I think it would have been an interesting pivot to get a QL type of design, but completely makes sense to say, the priority here is the module. Let's just build it on that.
It didn't fit with what we wanted to do. And you will later on see some inspiration from this in how our keys are arranged and how our keycaps are made. So many of the benefits revolve around key spacing and key reachability, especially vertically. And that also you will see reflected in how our keycaps are shaped, where we should put the centers of the keycaps, and our general spacing that mimics that kind of distance.
Right.
And our travel distance now actually for most keys is lower than what you would have on a standard keywell on a menu form.
It's pretty good actually. So there were a lot of interesting findings, regardless of this actual design being thrown away, there were still some interesting findings.
Yeah, that is what I meant before by you take 2 steps forward and 1 step back.
Yeah.
Even if you don't end up integrating a certain feature, you have still learned a lot about that feature and what it is good for and why it is done. And you really want to figure out the why, because that often allows you to use a different method to reach the same goal.
Yeah.
And that different method could interact better with what your keyboard is supposed to do. So it might not always be the right choice. Sometimes a keywell is the right choice, and sometimes it is not. And in this case, we decided that this wouldn't fit the audience style and focus of the board. So we integrated it, the main benefits of it in a different way.
All right, super cool. And so I guess the natural progression from the keywell prototype was here or here?
Here we split paths a little bit.
Okay, so we have a branching sort of path.
Right. There are still some other features that we experimented here with, but we'll get to those at a different point in time.
Mm-hmm.
So here, the path is split a little bit.
Mm-hmm.
We have so far only talked about industrial design and about the visual arrangement of things. We have completely ignored so far all of the functional testing, which of course went completely parallel to this in a different track.
Of course.
And here I wanted to bring these in. Just because they will merge in the next steps. So I thought this would be a nice addition.
Mm-hmm.
So here we have one of the later versions of the printed parts, where we really have most of the features there. We now also have some of the waterfall keycaps on here. Here we have one of the later versions of the printing, where we really made the entire keyboard in one full set and brought everything into one print together. That meant some deviations on our pin arrangements, some of the integrations of all of the experimentation we had done before. On the underside, that meant some of the features we retained, for example, the sliding feet that we experimented with, or the cut-off teardrop, the vertical pogo pins. Basically, everything we thought was good from our experimentation steps, we put into one unit and said, okay, that's where we're at currently.
Right, okay.
That's what we're aiming for. Let's try this out.
Mm-hmm.
When I say let's try this out, that means we try out bringing this together with the electronics testing. So the electronics testing always looks vastly different from the shape testing. And eventually you arrange one point where you say, okay, let's converge, let's try.
So that's why this looks super bulky and kind of put together. Because it's just about pure function.
Correct. In these units, we never care about what they look like or what they actually specifically can do or can't do. We usually only care about a single feature. So for each electronics piece, we always say, okay, what is the thing we want to show with this? What is the one thing we have to prove that it works so that we can move on? So for example, this one, despite it having a cable, was our first tests for our wireless protocols.
Okay.
So that is really where we started testing with wireless integrations, our reprogrammability, OTA, etc. And of course also with the functional hinges. So this is where we started also testing some of the resistance hinges, while all of these did not have any resistance on their hinge, because we would need custom hinges for these dimensions. And on these larger, bulkier units, it was much easier to test these things and to figure out which dimensions and which sizes, which types of hinges, which mechanical properties we would actually be needing, and how that would all end up working.
So these have I wouldn't say the final hinges, but like this is kind of already a step towards saying, okay, how would the hinging or the tensing work in a typing environment, or like in like a situation where you're actually applying typing forces onto the keyboard, and does it hold up? So
these are very much a proof of concept. So it is to show that the concept and the idea of this type of hinge and this arrangement will work, but the actual hinge used is an off-the-shelf component. Instead of a specialized component. So its actual properties are vastly different. But these are what we can use off-the-shelf components, larger, bulkier units, electronics tests, etc., to put them on a table in our office and say, hey, let's try it out. And if this works, we're sure we can make the other one work too. So you always try to be more conservative on your unit, where you try to always make it in a way, if this works, I'm sure the other one works too. And not too optimistic where you're like, and if we get a bit better, then the other one will work. So really, that nice. Was one of these. But there are plenty more of these, and we will talk about that.
Could you potentially demonstrate the hinges like while typing? Because a lot of people are actually quite curious about whether or not they're strong enough, like to use while typing.
So this is one of the earlier versions.
Maybe the camera above.
So let's make some space. So this is again one of the earlier versions, and as you can see, these hinges move around a lot. So these are not glued in, they are purely friction fit into the nylon. And despite them not being custom made for this or really fixed in place, there is very little concern. I will move the entire keyboard before the hinge gives in. So I will have to hold the keyboard on the opposite side so it doesn't move. And despite me really hammering onto the keyboard, there is no chance that the hinges would give in. So we could show with this that there is no risk of the hinges ever giving in. Despite this being a configuration where we used 2 hinges on one side and 1 on the other, which we will talk about later. We have changed since, just to stabilize this part even more, not because of the resistance need, but because of twisting need. So you see here how this entire part moves around the hinge.
There's still a bit of torsion there.
Yeah, exactly. And that torque over time would damage the hinge. Hence a change we will see later.
Interesting. Yeah, I think we'll make a more focused spotlight on like perhaps the typing on this specific demo or prototype, just to make it a bit more clear exactly like what it looks like from all angles, like while typing, and
Absolutely.
showing the hinges and everything. But yeah, super interesting actually. So I guess this one here is a result of putting these two together, right?
Exactly. That is exactly what this step is for. You have a functional unit that has some of the features. There are multiple more of these.
Mm-hmm.
And you have a visual unit where you say, oh, this is what we would want this to look like. This is where everything should end up.
Mm-hmm.
And then your goal is to put that into one. And that is one of the most nerve-wracking moments, because if you messed up anywhere in the process, suddenly your things don't fit together, and you made calculation errors in your dimensional needs, and your visual prototype doesn't actually fit the components, or you run into problems with the pogo pin and you do a few steps back. All of these kinds of problems. But also you use a lot more components that you have made for the board.
Mm-hmm.
So you have to make sure that those are all right, and that the manufacturing methods that you're using are correct, that everything of this is actually manufacturable and scalable.
Right.
So making one in this case would be the easy part, but then you figure out after one that doing this 10 more times or 1,000 more times is going to just not be feasible.
Yeah.
So yeah, that's all of the learnings from these engineering samples. So very much engineering samples, hence all of the tape and the cables and everything. Yeah.
Okay, super interesting. Yeah. So I also wanted to mention that like the reason why we're not going into any of the modules in specific is because we wanted to focus more on the industrial design of the keyboard itself, the form factor, just like the design decisions behind the keyboard itself, and we're gonna have dedicated episodes going into way more detail about the modules specifically. So yeah, any potential questions or concerns that you have about the modules, maybe you can like leave in the comment of this video or in the Discord, and then we can like plan for that episode as well based on the feedback that you guys give us on this one. But yeah, moving on. Super exciting though, because from here I think it's the first sort of almost materials test as well, like moving away from the powder prints to more sort of maybe accurate representations of what it could be in the end.
Material wise, it's pretty close. Yeah.
Material wise, yeah. So what materials exactly like are being used in this one in particular?
Right. So the majority of the body, or basically the entire body, is made out of aluminum. We wanted the entire board to feel sturdy and have a certain heft to it, because as you've seen before, when I tried this out, it would slide around despite the chunky body of it.
Right.
We wanted something that feels exactly as luxurious as the function of the product is. So really matching the design, feel, and function. And that required, everything to be made out of metal. And there's multiple different manufacturing methods involved for every single component in there, from the dock to the body to the wing to the hinges, to all of the parts in between. So that is the vast majority of it. And then, of course, regular switches and caps. We will talk about those at length in a different episode, because they are a journey in and by themselves, in addition to the diffusers and some of our light guides on the side, for some additional status LEDs, battery status, etc. Yeah, that is already the majority of it. And then, of course, on the inside, a ton of electronics and magnets and
And this is already functional as well.
Yeah, so these are engineering samples, and the goal for these is indeed to be functional. So this one works wired and via Bluetooth. It does not have RF capabilities on this version, but the goal for this one was really to get the PCB tested, to get the module connection tested, and this is also functionally alike to what we showed at CES in January. Visually, it's not quite the same because tapes and cables, etc.
Right.
But generally, this is pretty close to what we had there.
So typing on this is possible?
Absolutely.
Okay. Nice. Okay. Just curious, because it's super interesting to see, because this is quite early compared to the one that we have over there, right?
Right. So the main, this is what I was joking about before, with generally your steps tend to get smaller. There are some exceptions to this.
Yeah.
Looking at you, Beaky.
Yeah.
So here we really tried to get the functions ready and to show the
Yeah.
product, because this was the
Let's
first
get
time
a
we
side
ever...
by side maybe with these
Right.
two.
So this was the first time we ever showed the product publicly. So this is where we, made a bit of a splash at CES with an innovation award and more. That was such an exciting time.
Yeah. Can imagine.
After working on the product for so long, for the first time,
Mhm.
showing it to the world and saying, "What do you think?" And of course, we all knew there was going to be a lot of feedback, and that's exactly what we asked for, and that's exactly what we got, and it was amazing. And it led to some of the much bigger changes between these two versions. Even if only one of them is really visually immediately obvious, that is the Beaky. The other ones are not quite as immediately clear, but yeah, there's quite a lot under the hood that has happened here.
Yeah, so just to give some viewers some context, the B key was a certain thing where in previous prototypes we had on the right side of the keyboard, right? And there were a lot of people who gave feedback saying it's quite odd to have the B key on the right side because it's more ergonomic to have it on the left side. And yeah, Moritz, maybe you can explain like how we kind of took that feedback and took it into our prototyping process.
So there is a lot of background to this. Obviously, that being requested was not a surprise. And in many earlier versions, you can see how we already had like key slots in it to test this out and to have it in or out. And it was always this, who exactly is it for? Depending on who uses it, this might be an absolute deal breaker,
right?
Or it might not matter at all.
Yeah, because it's kind of an interesting debate, I think, because I mean, there's definitely some people who press the B key with their right hand while touch typing, and there's also people who do it with their left. For me personally, I do with my right. Yeah. And so I think it's also very interesting to say, okay, if we had to split the keyboard in half, which side would it be on, right?
Right. For anyone who learned to type traditionally, they will type their B with their left hand. But it is interesting that the split between these is about 65-35, with the left side being the more common one by far. Yeah. But much of this layout was so custom already that we deemed it more important to have the module closer to your hand and in a more accessible location than our consideration for having the B key on the left. We just assumed that if you would jump to a keyboard like this in the hyper enthusiast market, that you would be fine with relearning this. But in the hyper enthusiast market, this remained true. But this product is way beyond the hyper enthusiast market. Right. And that was much of the debate that was going on at the time. Who would be using it? It became rather clear that the majority of our audience would prefer the B key to be shifted.
And how much did this throw a wrench into the works in terms of prototyping timelines and everything? Because this had to kind of be an interesting one to take a step back and say, damn, I have to now redesign the entire keyboard.
Yeah, luckily it wasn't too bad because we knew that this was going to be a topic. We had tested it plenty beforehand. You will find some of the other prototypes having a key on the side. So we knew how we would tackle this. We knew what we had to do. That's also why it was fairly sensibly time-wise doable between running a survey, getting the feedback, and integrating it. But there were some challenges because the main reason we didn't add a key on the left side immediately wasn't because we assumed that everyone would want to type the B on the right. The main reason we did this is because of how the internals of the system work. So basically, there is a cable connector running from the main board to the dock. And this connector runs at the bottom along this hinge, and it has to be in line with this hinge to not damage the cable over time.
Right.
Hence, we would have this hinge in the center of the keyboard to avoid torque from one side being too high. And that would put this hinge block directly in the location of the B key. Hence, we cut that location out for the hinge to not have to shift the dock too far to get a B key and the hinge in that spot. And that became one of the major reasons why we would not move the B key to the side. Because otherwise we could just have a B key on each side, right? Yeah. And what we shouldn't forget about is that it isn't just about the B key being shifted. It is the entire lower row.
Right.
So your N and M would usually not be in these locations either. You would usually have them both under your index finger. So that became the much bigger annoyance for most people typing on this board style. So for the next version, we had to change something that would avoid the module being shifted too far out, because we do not compromise on the module functionality.
Yeah.
So that became the main topic we had to work around. And I think I mentioned it when I talked about one of the functional prototypes beforehand, or at least I foreshadowed what would happen. We split the hinge into 2 blocks, arranged these blocks where previously we ran the cable, and in a second location under the enter key. That was space-wise a little bit more challenging and made some of the components a little bit more tricky. It changed some of how we had to arrange components on the PCB, how we would connect things, etc. And made some of the processes a little bit more intricate in the beginning.
Yeah.
But as we worked more into it and figured out what the constraints are for this kind of arrangement, it is now the much more stable version, as it avoids torque and like rotational forces on the hinges much better than a single centered version would. And it, of course, also allows us a much nicer tuning of the hinges because we simply have more area dedicated to it.
Yeah. Nice. And so, yeah, like, okay, I guess we already did go over some of the differences between these two.
Yeah.
The other difference, I guess, is also with the thumb cluster switches, right?
Right. So on our dock keys, you see a change in the switch that we have used here. So there are currently no keycaps on here. We are, of course, still using our regular waterfall keys. You have seen them plenty before. But here we have a difference in the switch that we used, because we noticed that the activation of the switch direction, so the pressing on the front edge of the switch, would tend to unclick the switch from the cap from the switch.
Yeah.
So the direction that you would push it would clip the cap out of the switch. So we had to avoid that problem. Turning these resulted in mechanical limitations between the components, which we could have worked around. But instead we went for a much newer design style of switches that multiple companies are currently working on, which tend to be much more binary in their force curves. So most switches are fairly linear in the force they require at certain points. If they have tactility, they of course have a bump in their tactility. But more or less, the force required before or after actuation is mostly equal. On these switches, that is very different. They really prefer 2 states. They prefer to either be pressed or not pressed at all. So once you overcome an initial force that is needed to move the switch at all, they immediately switch to their second state of being pressed. The reason this is interesting is because these keys are very often held. So they aren't as much used for tap. They're often used for hold, for example, for a layer key. So you would hold a layer key while you then have a numpad.
Yep.
And this hold motion is a lot easier if you have a binary key, because you aren't somewhere in between. You simply bottom out the key entirely, which for pure typing isn't quite as nice from a feeling perspective. But for these toggle keys or hold keys, this is the better option to go for. Hence, the force curve simply matched the type of switch or the type of application much better. And it's another very nice example of neither of these is better or worse. They're just meant for different things.
Yeah, okay. Super interesting. This is not the final prototype that we have currently. Like, I guess, I don't know how many do we have currently in Taiwan, and like what are the states of those prototypes?
Right. So what we have here is the unit that was used for the filming of the Kickstarter.
Yeah.
This is not the latest version, because our latest versions are always used for development first. And the development versions are in Taiwan. So there are 2 iterations past this already. But yeah, those will come up at some point soon.
Okay, nice. So they're there because we want them to serve as much of a function towards development as possible.
Right. Our first goal always is to advance with making the product. And then, sadly, the second priority is showcasing everything and making sure that we get enough feedback on it.
Naturally, yeah. Nice. I think we've gone through the timeline quite quickly, actually, considering, like how many there were. Do you think there are any interesting anecdotes that you'd want to share in regards to any of these around the table?
Prototyping's hard. For anyone starting out on a project like this, be prepared that you will have to test a lot, and that a lot of the ideas you initially have will later on prove to not really be that fruitful. And be prepared to kill your darling. It happens over and over and over, but if you stay open to improving your product, and if your mindset is always to search for the next better thing, and if your goal isn't to make the thing you wanted to initially make, but to make the best version of it, you will get to a very, very interesting result, and often something that is quite unique.
Right. So the key here is to not be too stubborn or stuck on a specific vision. Obviously, you have certain design requirements in mind that you build around, but to not necessarily be blind to the findings that you have during testing, during prototyping.
Exactly that. Just be open to new ideas.
Yeah, nice. Okay. I think we've covered quite a, I think, in-depth sort of portion on the overall evolution of the Naya Create, from paper to 3D prints to materials testing. And also functionality briefly. I think it'll be super interesting to, in our next talk, maybe get Kalen in, invite him over to discuss some more functional properties.
Talk about his handiwork over there.
His handiwork here on this very nicely looking, almost bomb-like construction. Hopefully I think the next one will go into more of a functional approach towards the prototype, like prototyping in general. I enjoyed having this discussion, just going over the design aspects and the hidden quirks and tweaks here and there. Overall I think
it was a good one.
Yeah, it was a good one indeed.
Can you imagine how fun it is to take this through airport security?
Yeah, I wouldn't personally do that, but indeed.
Okay, then thank you for the interview. Let's wrap it up here.
Likewise. Thanks again, guys. As always, always invite you to participate in discussions in the comments below. Always love to hear some feedback and to have more one-on-one discussions on the Discord as well. Thanks again for watching, and hope you see you in the next one.
Talk to you all soon.